So let's look a little bit closer at stoichiometric calculations. Recall that substances will react in the ratio given by the coefficients in your balanced chemical equation. So that's always the starting point for stoichiometry. Is you need to have, first of all, a balanced equation, and then recognize that those coefficients represent the ratio that the substances react in when that chemical reaction occurs. It does not represent the mass ratio, however, so you have to use your periodic table to find the formula masses or the molecular masses or the molar masses of each substance so that you can see the quantities or the relationships they will react in grams. So those coefficients will give the ratio of the moles, and then starting with the mass of one substance, you can use the molar mass to get the moles of that substance, and then use the ratio of the coefficients to determine the moles of another substance, and then finally use the molar mass to determine the mass of that substance. So it ends up being generally a three-step process, always passing through moles to get from one measurable quantity of one substance to the measurable quantity of another substance. So for example, if you started with 1 gram of glucose and you wanted to know the number of grams of water that would be produced, you would calculate from the mass, you would calculate the moles, and then from the coefficients, calculate the moles of water, and then use the molar mass of water to determine the mass of water. How does it work when you have a limiting reagent? So when there are limiting reagents, we're usually referring to the fact that you're given two quantities of starting reactants, and you have to determine which of those quantities is actually going to limit the amount of product that's formed. So a good example would be from cooking, right? If you want to know how many cookies you can make, well, you can only make cookies until you run out of one of those ingredients. So if you need butter, sugar, flour, milk, and eggs, which of those is going to limit the number of cookies that you can make? As you can see here, without even measuring these quantities, you don't have very much sugar. So once you run out of sugar, you will have to stop making cookies, or they'll just not taste very good. So in this example, sugar would be the limiting reactant, right? Because that limits the amount of cookies that you can make. So the same thing occurs in stoichiometry. So for example, if you have hydrogen and oxygen gas reacting to form water, well, hydrogen and oxygen gas have to react in a 2-to-1 ratio, whereby you have twice as many molecules of hydrogen as you have oxygen. So with 10 molecules of hydrogen and 7 molecules of oxygen, you can basically here, as you can see, you can produce 10 molecules of water, but you will still have 2 molecules of oxygen left over. So oxygen is in excess. You will run out of hydrogen first, using 10 molecules of hydrogen and 5 molecules of oxygen. So hydrogen is your limiting reagent. Now, the yield, which is the theoretical yield, is the maximum amount of product that can be made based on the amount of limiting reagent. There are several ways to determine this. Some students find it easiest just to use both quantities to determine how much yield can be produced, and then whichever produces the least must be the limiting reagent. The actual yield is the amount that you actually produce and measure when you conduct the reaction. So you can determine the percent yield by taking the actual yield, dividing it by the theoretical yield from the calculations, and then multiplying by 100. Hope this was helpful. Bye.